Significant heat transfer can occur through an uninsulated roof. This heat transfer can occur in different ways, so a range of strategies is needed. Strategies need to consider the roof as a system. Firstly, as with walls and windows, insulation limits the heat transfer between the roof and outside. Insulation may be applied on the inside of the roof element itself or on the roof deck. Secondly, any roof penetrations, such as pipes, ducts, or chimneys, have to be very well sealed, otherwise they will present a weak point or shortcut for heat transfer. Thirdly, a radiant barrier, which is a low emissivity reflective surface, can be applied to the internal surface in order to reflect back out heat absorbed from the sun outside. And fourthly, ventilation to outside is important to prevent moisture from collecting in the roof space or within the roof construction. Excess stagnant moisture can grow mold and compromise the effectiveness of the insulation. The color of the external finish also affects how much heat is transferred through the roof. A white surface has a much higher reflectance than a dark one, transferring much less heat to the inside. This is especially important in hot climates. Solar reflectance can also be altered by applying reflective pigments. These reflect near-infrared waves, which reduce the heat transfer to the surface. This is one of the strategies to reduce the urban heat island effect in cities. A big contributor to the urban heat island effect is when low reflectance building surfaces heat up. In dense areas, these hot surfaces may increase the temperatures in cities by several degrees. Increasing the reflectance of surfaces may mitigate this peak in temperature. Air sealing is a technique to avoid unwanted air from traveling through leaks in the building fabric or through systems such as ventilation ducts. It is easy to apply in the form of foam that expands when applied. Infrared cameras can be used to visualize the temperature distribution, finding hot or cold spots that might indicate a leak that needs sealing. The air sealing of the building envelope is measured by blowing air into a sealed opening of a building, for example through a door. This provides a pressure reading that is the baseline for measuring how much air leaks out over a given amount of time. This can be measured in either volumes of air per hour per meter squared of the building envelope, or in air changes per hour, that is, how many times the volume of the air in the building is renovated in 1 hour. This is a costly and complicated measurement to take. More research is needed to find simpler ways of assessing the tightness of a building envelope.